Today we're looking at notes CC-1, Intro to Sequences and Factorials. So first we'll begin with talking about factorials. Factorials are notated with an exclamation point, and it means to multiply going downhill to 1. For example, if you have, on number 1, 2 factorial, that's how that is said or read, then that means 2 times 1, which equals 2. And on example number 2, we have 3 factorial, which means 3 times 2 times 1, which would equal 6. I'll box my answers here. All right, and then last example for factorials, number 3 is 4 factorial, which means 4 times 3 times 2 times 1, which would equal 12 times 2, which would be 24, and of course 24 times 1 would be 24. All right, so that's about it with factorials. We'll be using them today within the assignment. So on Roman numeral number 2, we will be talking about using an explicit formula. So within this part of our notes, we will be talking about how to build a sequence as well as how to jump to a certain term. So first let's start with how to build a sequence. So the directions state find the first 3 terms. So number 1 is a sub n equals 3n plus 1. Okay, we are going to assume that we are starting at n equal to 1. So a sub 1 equals 3 times 1 plus 1, which of course equals 4. Then a sub 2 would be 3 times 2 plus 1, which would be 7, and a sub 3 would be 3 times 3 plus 1, which would be 10. So therefore I have the first 3 terms. So 4, 7, and 10. All right, so number 2, a sub 1 is equal to negative 1 raised to the 1 plus 1, remember n is 1, times 7. So this is like negative 1 to the second, which would make that negative a positive, so it would just be 7. So then a sub 2 would look like negative 1, 2 plus 1 times 7. So of course that's going to make an odd exponent. When I raise a negative 1 to an odd exponent, it would remain negative, so this would make negative 7. And then a sub 3 would equal negative 1 raised to the 3 plus 1 power times 7. So again, now I have a even exponent, so raising that negative 1 to an even exponent would make a positive. So then we would have positive 7. So my first 3 terms are 7, negative 7, comma 7. All right, moving right along to the next one. So a sub 1 equals negative 1 to the first over 1 squared. Okay, so this is going to equal negative 1 over 1, which is negative 1. Okay, and then a sub 2 is going to be negative 1 squared over 2 squared. So this is going to make a positive 1 over 4, so 1/4. And then a sub 3 is going to be negative 1 to the third over 3 squared, which is going to equal a negative 1 on top over 9, so negative 1/9. Okay, so my first 3 terms are negative 1, 1/4, negative 1/9. All right, and last, a sub n equals 2/3. Well, there's nowhere to plug an n in anywhere, so on this problem, no work needed. Okay, so no work needed on this guy. Your first 3 terms, along with all your terms, are going to be 2/3. So 2/3, 2/3, 2/3. Isn't that nice? Okay, so before we move on, what I do want to point out to you is, hopefully you notice that 2 out of these 4 formulas were special. They were special because within our answer, we switched back and forth between either positive to negative or negative to positive. So you probably noticed that these are the 2 I'm talking about and what made them switch back and forth between negative and positive or positive and negative. And of course, it's going to be that -1 raised to some power. So this right here, and this right here are what make signs alternate. Okay, so this makes signs alternate. And furthermore, this n+1 here will start positive. While, of course, just the n will start negative. Okay, so when we start to make our own explicit formula, you'll definitely want to keep that in the back of your mind. Okay, so let us look at number 5. And on number 5, we're still finding the first 3 terms, but we're going to assume n begins with 0. And notice we have our factorial here, so that's exciting. Get to start using that. So a sub 0 equals 1 over 0 plus 1 factorial. So what does that really mean? That means 1 over 1 factorial, which is just going to be 1. And that's my first answer. So then a sub 1 is going to be 1 over 1 plus 1 factorial, which will be 1 over 2 factorial, which 2 factorial, as I'm sure you already know, is just 2 times 1. So, of course, that's going to be 1/2. All right, so then a sub 3 is 3. Hello. A sub 2 is going to be 2 plus 1 factorial. So this will be 1 over 3 factorial. So 1 over 3 times 2 times 1, which is going to be 1 over 6. So our final answer for this, I shouldn't have really probably been boxing along the way, 1/2, 1/6 is my final answer. So if you want to take those boxes off, maybe, since that's not really our final answer, if it'll bother you, we didn't do it on the rest. Might bother me a little. Okay, so let's talk about jumping, part B, jumping to a certain term. This is definitely going to be important as we move along this lesson. So say we want to find term 10. You don't want to have to find term 1, 2, 3, 4, 5, 6, 7, 8, 9 first. It's nice to just be able to jump to term 10. Okay, so let's use this formula to jump to term 10. And with an explicit formula, you can do that. So a sub 10 equals 10 times 10 squared minus 6. Okay, so then, don't have a whole lot of room to work. A sub 10 equals 10 times 100 minus 6, so 94. So a sub 10 equals 940. That's what is so nice about an explicit formula. You can jump to a specific term. Let's now look at what's called a recursive formula. So a recursive formula builds on the previous term. So they must give a starting number. This makes a 2-part formula. So what's a bummer about recursive formulas is you cannot jump. Okay, you always need that previous term, and that previous term needs the previous term, so you can't just jump. You have to follow the order in order to find the next term. So it is unfortunate, but this is a type of formula you will see. So let's talk. Find the first 4, not 3 anymore, terms. So a sub 1, the first term is 3. Okay, so this is the first term. while a sub k plus 1 stands for the next term that you want to find, and a sub k minus 1 is the previous term. Okay, so a sub 1 is given. It is 3. So a sub 2 is equal to, all right, so this is going to be 2 times our previous term minus 1. So this arrow doesn't really look like it's pointing to just this. I just want to make sure it's not the whole thing that you think. It's just the a sub k that is the previous term. So the previous term is 3 minus 1. So this is going to be 2 times 2, which is 4. So then a sub 3 is going to be 2 times the previous term is now 4 minus 1. Okay, that is the previous term where that was the previous term. Okay, so this is 2 times 3, which is 6. So then a sub 4 is equal to 2 times 6, because 6 is the previous term, minus 1. So this is going to be 2 times 5, which is 10. So our first 4 terms are 3, 4, 6, and 10. Okay, so again, a sub 1 is our first term. A sub k plus 1, this whole thing, stands for the next term. Okay, and then the a sub k means the previous term, and we're going to take the previous term and add 4. So a sub 1 equals negative 8. Okay, so then a sub 2, our next term, is going to be equal to our previous term, negative 8, okay, plus 4, which is going to be negative 4. So then a sub 3 equals our previous term, negative 4, plus 4. So that equals 0. So a sub 4 is going to equal our previous term, 0, plus 4, which is equal to 4. So it is, for our final answer, our sequence is, the first 4 terms are negative 8, negative 4, 0, 4.